here we have section, that's an S, section 2.4, exercise 78. This is a chain rule problem with technology. So we're told that y is equal to cosine of what? 3x. And what we're asked to do is determine the derivative and plot the tangent line at this value, pi over 4 and negative square root of 2 over 2. And just checking, right, if x equals pi over 4, then that's cosine of 3 pi over 4. Well, 3 pi over 4 is over here, and so that's you know, this reference angle here is 45 degrees, or pi over 4, and so 3 pi over 4, and so I know that triangle is a 1 1 square root of 2 triangle, but that's a negative, and so cosine is negative 1 over the square root of 2, but if I multiply top and bottom by square root of 2, I get my minus square root of 2 over 2. So yep, that looks good. Now, so if I want y prime, well, I have, well, let's write down what we have here first. Right, we have cosine of something, and then that something happens to be 3x. As I look at those derivatives, derivative of the cosine is minus sine of that something that we put in there, and the derivative of 3x is 3. And so when we do y prime, we get our minus sine of the 3x that was inside there, and then times 3. So I would rewrite that as minus 3 sine of 3x. So there's our derivative, and now at pi over 4, so y prime at pi over 4 is minus 3 sine of 3 pi over 4, and I put pi over 4 in there. And so that's negative 3 times, well, it's that same reference angle, but the sign is positive there, so we could write it, I guess, as the square root of 2 over 2. And so that's our number, minus 3 times the square root of 2 over 2. And so our tangent line there, L of x, well, again, that's just point slope sort of thing, so that's minus 3 square root of 2 over 2 times x minus pi over 4, and then our y value is minus square root of 2 over 2. So there's our tangent line, and so let's check all that stuff out. We can go here to Desmos, and our original function, I'm going to call it f of x. So I need an f here. F of x is equal to cosine, so my functions here, cosine of 3x. So there's the function. Now we were at pi over 4. Trying to make that a little bigger. You know, now pi over 4 is like at 0.75-ish, somewhere in there. We could actually plot that point. Oops, not sure what I did, but we could plot that point by just making that point. So pi over 4, there's pi divided by 4. And come out here and do a comma. There's a comma, and then f of pi over 4. So f of pi divided by 4, and close those, oops, go back here, need to go out there and then do a parenthesis and another parenthesis. And so I should see that if I move this thing, there's the point. So we'll move it up here where we can see it even when our keyboard is out. And so there's that. Now we can plot our line, right? So when we did this, then and remember we had minus square root of 2 over 2, so we can put that in there. But we had L of x, so there's L of x, and that is equal to, and let's see, I need to come back here, what the heck did we get? Minus 3 times the square root of 2 over 2. Okay, so minus 3. Okay, so negative 3 square root of 2, and then move that out and do a divide by 2. Okay, move that all out, and then that's times x minus pi divided by 4. Get our parenthesis in there, and then that point was at minus square root of 2 over 2. So square root of 2 divided by 2. And look at that, looks like a tangent line to me, so it looks like we did very well. Now, and we can check that actually. We will, I won't give it any particular name, but remember what that is. That's the derivative at pi over 4. So we'll say y equals f, shift here and get the prime. So there's f prime of pi over 4. So pi divided by 4. Okay, so there's our derivative times x minus pi divided by 4. Okay, and then plus f at pi over 4. So here, I personally did no calculations whatsoever. I just made sure all the information was in there. And notice the blue line is right over top of the green line, right? So if I turn that off, well, I've had trouble with that before. I can't, I don't know what the problem is, but oh, there we go. I got it off. So I turned off the blue line. We see the green line. I'll try to get it turned back on here. Got it turned back on. There it is, the tangent line. So, you know, that's nifty with Desmos is I can truly just tell it what I need here, right? You know, I used my pi over 4x and then just the symbols of f prime and f. Now I had to, you know, up here I had to define what f of x was, but once I had it defined, I could just symbolically tell it, well, this is what any tangent line would look like at pi over 4 for any function f, and it draws it for me. You know, it doesn't tell me what the derivative is, but I certainly have the tangent line there. And I could determine what that slope is simply by evaluating f prime. I wish I could do a copy and paste, but I can't seem to highlight on here. So So f prime of pi over 4, oops, keep getting trigger happy here, get rid of that, and there we go. And we see that's minus 2.1213, so there's our decimal approximation to the square root of 2 over 2. And if you wanted to check that, well, just do the square root of 2 over 2. So square root of 2 divided by 2. And, oh wait, it was 3 times that. Yeah, sorry. Put that 3 out in front. And there we go. I didn't have the minus sign in it, but you can see the numbers are the same. So, there we go. We checked that tangent line and graphed it with that, and it looks lovely, right? So that was, what the heck was that? Number 78.